In this module we are studying about fluid dynamics. Fluid dynamics is the study of forces causing the fluid flow. So there are several forces that is acting in a fluid flow. We will see each one of them in detail. And this dynamic behavior is analyzed by Newton's second law of motion. Here we are making some assumptions. These assumptions are: the fluid is ideal, that means viscosity is 0. So this assumption is only made when we are deriving Euler's equation and Bernoulli's equation. Otherwise this assumption is not made. So what do you mean by the equation of motion? So according to Newton's second law of motion, net force will be equal to mass into acceleration in that particular direction. So if you are taking the x direction, so this will be equal to mass into acceleration in the x direction. So what are the various forces acting in the fluid flow? So these forces are pressure force. So first one is a gravitational force, that is force due to gravity, and then force due to pressure, and force due to viscosity, force due to turbulence, and force due to compressibility. So the net force will be the sum of these forces, that is pressure force, gravitational force, viscous force, turbulent force, and compressible forces. So if compressible forces are neglected, then you will get the net force will be equal to gravity force, pressure force, viscous force, and turbulent force. And this is called the Reynolds equation of motion. That means you are neglecting the compressible force. And if you are neglecting the turbulent force, you will get the Navier-Stokes equation of motion. So in Navier-Stokes equation of motion, you are considering only gravity, pressure, and viscosity. And if you are neglecting the viscous force, then you will get the Euler's equation of motion, that is Fx is equal to Fg and Fp. We are considering only two forces, that is pressure force and gravitational force. So I told you for Euler's equation of motion, Fx is equal to, the force we are considering is only gravitational force and pressure force, and this will be equal to mass into acceleration in that particular direction. If you are taking x, so acceleration will be in that direction. So consider a stream tube. A stream tube means so all the streamlines are enclosed inside this streamline. These are the streamlines flowing in this direction, and this has got a cross-sectional area of dA, and the length is ds. So the pressure force acting here on this side will be P into dA, and pressure force acting here, it will be in this direction, that is P plus dou P by dou S into ds into dA. So this quantity, this is actually equal to, that is delta P. That is the change in pressure when you move from this position to this position. So it can be positive as well as negative. So this is dou P by dou S is the rate of change of pressure, and ds is the length. So this into dA, and we have the gravitational force that is acting downward. So this is equal to rho g into dA into ds, and this angle is theta. So here also if you are taking this angle is the theta, that is the angle that is made with the streamline. So you can see that the vertical height of this stream tube will be d into z. So you can use the theta here. Both these angles are equal. You can find cos theta and sin theta. So let us see what is the gravitational force Fg in the direction of streamline. Okay, so that means this Fg is resolved along the streamline. So in this dash, it can be resolved like this. Okay, so this will be equal to rho g dA into ds into cos theta. If you resolve the force, that means you are finding the gravitational force along the direction of a streamline. And FPS will be equal to, that is pressure force will be equal to, in the direction of streamline, is equal to P into dA minus P plus dou P by dou S into ds into dA. So, and according to Newton's second law of motion, pressure force and gravitational force is equal to mass into acceleration. So acceleration in the direction of streamline, not in the x, it is the, we are taking along the streamline. So you know that Fp is equal to P into dA minus P plus dou P by dou S into dA. From here, minus rho g dA into ds into cos theta, that is from here. So this will be equal to rho into dA into ds into dV by dt. That means As is equal to dV by dt. That is the acceleration. So this will be equal to P into dA minus P plus dou P by dou S into ds into dA minus rho g dA ds cos theta is equal to rho into dA into ds into this acceleration dV by dt is equal to V into dou V by dou S. We will see how we got that. So see, dV is equal to dou V by dou S into ds plus dou V by dou t into dt. You can write it like this because V is a function of S and t. So this will be equal to dou V by dou S into ds plus dou V by dou t into dt. So that means dV by dt will be equal to dou V by dou S into ds by dt plus dou V by dou t. And if the flow is steady, dou V by dou t will be 0. So this will get reduced to dV by dt is equal to dou V by dou S into V. So the equation becomes P into dA minus P plus dou P by dou S into ds into dA minus rho g dA ds cos theta is equal to rho dA ds into dV by dt. So this is the acceleration. But dV by dt is equal to dou V by dou S into V. We will substitute that here. So this is substituted here. And we will simplify this. So on simplifying, you will get minus dou P by dou S into ds into dA minus rho g dA ds cos theta is equal to rho dA ds into V into dou V by dou S. And cos theta, you can write like this, dV by ds, because the triangle was like this, theta, and here it is ds and this is ds. So when you substitute that here, dz by ds, you will get minus dou P by dou S minus rho g dz by ds is equal to rho V dou V by dou S. That means you are cancelling this rho and dA ds. You will get dou P by dou S. So for the simplification, you will get dou P by dou S plus rho g dz by ds plus rho V dou V by dou S is equal to 0. And when you divide it by rho, you will get this equation. And this is similar to, this can be written as dP by rho plus g into dz plus v into dv is equal to 0. Also, this is for a particular streamline. So generally we can write this as dp by rho plus g is dz plus v dv is equal to 0. This is the Euler's equation of motion. So we have derived the Euler's equation of motion. This is the Euler's equation. Now we will find out the Bernoulli's equation. We will derive the Bernoulli's equation. So the Bernoulli's equation, the assumptions are these. The flow is ideal, that is viscosity is 0. This is one first assumption. And flow is steady. This assumption we have taken for Euler's equation also. And this flow is incompressible, that means rho is a constant and flow is irrotational. So these are the 4 assumptions we are using for deriving Bernoulli's equation. So for deriving Bernoulli's equation, we are simply integrating the Euler's equation. On integrating the Euler's equation, you will get dp by integrating dp by rho plus g is dz plus v dv is equal to 0. So this will be equal to p by rho plus g z plus v square by 2 is equal to constant. This is equal to p by rho g plus z plus v square by 2g is equal to constant. That means when you divide by g. And these terms, p by rho g is called the pressure head and z is called the potential head and v square by 2g is called the kinetic head. Head actually means energy per unit weight. Energy per weight of the fluid. Weight of fluid. So let us see what are the various energies we are considering. First one is the pressure head, or this is also called the static head. And we have the potential head. See, for potential head, that means, so potential energy is equal to mgz. So if you are dividing it by the weight of the fluid, this you will get z. So this is the potential head or energy per unit weight. And you have v square by 2g, or the kinetic head, or this is also called the dynamic head because of its motion. And plus z is called the p by rho g plus v square by 2g plus z is called the total head, or the total energy per unit weight of the fluid. So these are the various energy heads we are considering.